Welcome back to The Explainer. Today, we're following the script structure outlined in the source document titled ENGV to explore something absolutely mind-blowing. We're talking about June 1st. It's not just a regular day on the calendar, folks. It's literally a golden day in math history. And we're going to see exactly why. Think about these dates: 1796, 1941, 1947, and 2000. Across different centuries and completely different countries, on this exact same date, brilliant minds were asking some seriously profound questions. Questions that invisibly power the modern world we live in right now. Let's meet them one by one.
Okay, let's dive right into this. Have you ever actually stopped to wonder why your car engine works? I mean, really think about it. The hidden mechanics powering the cars and the buses we rely on every single day. Like, how exactly does liquid fuel suddenly become forward movement?
Well, for our first historical detective, we have Sadi Carnot, born on June 1st, 1796. He was the visionary who tackled the great mystery of steam power. So back in 1822, Carnot achieved something completely incredible. He essentially figured out the exact mathematical expression for how heat translates into physical work. It's kind of like a giant puzzle. He mapped out how steam, going through specific, distinct heating and cooling stages, actually produces motion. Now, sure, we don't really drive steam cars anymore, right? But that mathematical foundation he laid down, it's the exact reason our modern combustion engines are able to function today.
And that brings us to this huge aha moment. Carnot succeeded because of his, quote, careful, clear analysis of the units and concepts employed. By taking the abstract math of heat and turning it into a hyper-precise science, the guy basically built the literal engine of modern transportation. Absolutely crazy.
All right, we're still on June 1st, but we're going to take a massive jump forward from 1796 all the way to 1941. Time to meet a completely different kind of pioneer. Now, think about this for a second. How does your Wi-Fi securely transmit private data? You know, when you're sending a secure text message or you're checking your bank account online, how does all that sensitive information stay perfectly safe as it's traveling invisibly through the air around us? That brings us to number 2, Kurt Hensel, a genius whose life's work culminated on this exact date. He passed away on June 1st, 1941. Way back in 1897, Hensel invented something called p-adic numbers. Now, don't let that fancy name intimidate you. What he did was basically find a completely new algebraic way to measure the distance between rational numbers. It was a total fundamental shift from how we normally count on a traditional real number line. And, believe it or not, this entirely new way of looking at numbers became a foundational puzzle piece for the secure data structures we rely on every single minute of the day right now. What's really interesting here is that he realized you could achieve a, quote, completion of rational numbers in a different way. By simply shifting his perspective on the basics of how we count, he unlocked this massive technological potential for our modern digital safety. Just brilliant. Okay, keeping on the timeline, same exact calendar date, but just 6 years later. We're moving closely from 1941 to 1947. We lose another genius, sure, but we gain another world-changing idea. Have you ever wondered how we can actually predict incredibly complex things, like the weather or airflow? I mean, the air around us is just pure chaos, right? It's filled with billions of particles flying around in every possible direction. So how on earth do we somehow manage to predict its movements so accurately? Say hello to number 3, David Enskog, a brilliant Swedish mathematical physicist whose mind stopped working on, you guessed it, June 1st, 1947. Enskog is the mind behind the kinetic theory of gases. In simple terms, he used highly complex equations to actually track how billions of these invisible molecules collide, bounce off each other, and transfer momentum and energy within a gas. It's mind-boggling when you try to picture it. And this brilliantly illustrates the difference his advanced math actually made. See, simple theories completely failed to predict complex temperature shifts in gas mixtures. But Enskog's theory, it saw the hidden pattern. He mathematically proved that larger molecules will naturally concentrate at lower temperatures. He literally saw perfect order where everyone else just saw a giant chaotic mess. Enskog absolutely brought order to the chaos, because, as the text notes, he derived general formulas for viscosity, conduction, and diffusion. Basically, he proved that the random, chaotic air we're breathing right now is actually performing a perfectly choreographed mathematical dance. No way, right? One date. So many incredible stories. All right, let's execute our final timeline jump, leaping all the way into the digital age to June 1st, 2000. Think for a moment about the everyday magic of just opening up Spotify or YouTube. Why does your streaming music sound so crystal clear? Why does it load flawlessly against all odds, even when you have an absolutely terrible internet connection? Well, that brings us to number 4, Aubrey Ingleton, a modern mathematical genius we lost on June 1st, 2000. Back in 1971, Ingleton discovered a massive breakthrough rule known as Ingleton's inequality. Now, he was working in a highly abstract field called Matroid theory. And while that sounds incredibly complex, and honestly it is, his theoretical work actually became the secret backbone of modern information theory and network coding. He figured out the mathematical rules for exactly how complex networks can represent and share data efficiently. His work, which famously surveys the representability problem for Matroids and contains new constructions, literally mapped out the secret architecture of our digital networks. I mean, those seamless, crystal-clear internet connections we all take for granted, they are built entirely on Ingleton's abstract equations. It's a real game changer. So, the crucial point is really this. Every single person we met today, Carnot, Hensel, Enskog, and Ingleton, across completely different centuries and countries, are all connected by this June 1st thread. And they all fundamentally asked the exact same question. What is the pattern hiding inside the chaos? Because they asked that question, our world today is running on powerful engines, secure data, accurate weather prediction, and flawless digital streaming. They proved without a doubt that math isn't just numbers on a page, guys. It is the invisible engine of our reality. So I am going to leave you with this. What invisible mathematical pattern is hiding inside your smartphone right now? Keep asking those big questions, keep looking for the hidden patterns, and I will see you in the next